Okay, so hello and welcome to this next lecture in the ongoing series of lectures on digital prepress. In the last lecture, we completed, if I remember correctly, till different types of graphics. We classified graphics into two categories based on the fact that how they are being reproduced. One was your pixel based graphics, where we saw one problem was that it was not scalable. Okay, and the second was pixel based image, as I mentioned earlier, and the second was your object based graphics, which were created with the help of your Bezier curves. These are mathematical tools or mathematical functions, polynomials which determine how your curve will look like depending upon the number of control points that you include. In the font section, that is how different types of fonts are created and different types of fonts and font management systems. There we will see how we are using quadratic type polynomials to create one type of font and cubic uh, polynomials, Bezier curves to create the other type of font. So those things will be dealing later on. Now, in this lecture, as I told earlier also in the end of the last lecture, that we will be talking mainly about the some terminologies related to digital prepress, which we will be using later on in our lab classes and in practical work also. Okay, so let us start this discussion with the concept of bit depth. You are all familiar with this concept of bit depth. You are using this Photoshop and other image editing software, and you are taking photographs. You must be hearing this term bit depth a lot, right? At least you have uh, what should I say, some, not knowledge but awareness about this term bit depth. So what is bit depth? Now, what is bit? If I ask you what is bit, bit is the basic or the most fundamental unit of storage in any computing system or in a digital system, right? So any information that is stored in the computer or in your digital system is stored in the form of bit. Okay, one bit. So one bit means one unit of storage area. Okay, so, and why we are saying that depth here, the term depth refers to memory allocation or memory amount of memory. If you see the picture, the series of picture, if I mark this 1 2 3 and 4, what do you notice when you move, when I ask you to move your attention from picture number 1 to picture number 4? What is the primary uh, you know thing that is visible to you once you see this picture number 1 and then you see picture number 4? Just pause the video here for a minute, try to analyze yourself and find out the answer yourself. Okay, I will wait for a few seconds. Now, the primary difference or the primary aspect of this type of image quality, as you can see from image number 1 to image number 4, is the number of colors. If I ask you, in picture number 1, how many colors does this picture contain? Will you be able to say? Yes, of course, as you can see that it contains two colors. Here, you might have thought in your mind that the answer will be one, that is this particular violet color, but no. See, certain pixels, this is digital image, certain pixels are lit up, right, and certain pixels are not lit up, so switched off. This is a combination. Okay, so here you will say that although you can see only one color per se, but how many combination is possible? Two combinations. So here you will write two combinations. In this situation, how many combination is possible? See, there is violet color, no violet color, green color, no green color. If you think in that perspective, okay, there are colors are two. You understand, color here is one, but how many combination of those colors are possible? 2 in this first case. In the second case, there are how many colors? 2 colors, violet and green, right? But how many combination is possible? 4, and 4 colors. Similarly, as you move on to this fourth image, you will see multiple colors. If I ask you to count the number of colors in image number 4, you will not be able to do that very easily. Here it was very easy for 1 and 2, it was very easy for us to do, no? But for image number 4, it's not that easy. If I ask you that how many colors are there in this image, many colors are there in this image. Okay, so ultimately, what am I driving at by showing you all these pictures? I am trying to infer, or I am trying to get to the point that the image number 1 has lesser number of colors in comparison to image number 2 or 3 or 4, where image number 4 has the highest number of colors, color combination in this in this among these 4 images. That means if this is the case, then naturally the amount of memory that is required to store image number 1 is lower than the amount of memory that is required for storing image number 4. Do you agree with this or not? You must agree. Why? Because it is kind of a common sense that in image number 1 there is only one color, in image number 4 there are many colors. So if I want to store greater number of colors, right, then that will definitely need more amount of bit information to be stored, right, more amount of computer memory to store that same image. So from here we derive the concept of bit depth. Bit depth is the if I want to formally define bit depth, it is the number of bits that is required to represent a pixel. In this case, pixel means one unit of a digital image, right? So bit depth, if I want to formally define, it is what? It is the number of bits required to represent one pixel. Conversely, also you can say that the amount of memory required to save the image, right? Now, as you can see that it is formally written over here that pixels in image can be assigned different amounts of memory. I've already told you this is known as the bit depth. Now, depending on how much memory the pixels are assigned to, a corresponding number of color can be shown. Now, if you see, now you will understand why I was talking a little bit about the color combination. If you see picture number 1, again I am marking these pictures. This is just the numbering of the pictures, nothing else, okay? So in picture number 1, you will say how many colors did I say? 1 color. That means for representing one pixel, I am using 1 bit. Is it right? Now, for representing 1 pixel, I am using 1 bit information only. I am assigning 1 bit to represent 1 pixel. It was this violet color. But the concept here is, this is, so bit depth concept is now over. Okay. So that is what bit depth is. How much amount of memory is assigned to a particular pixel. It may be 1 bit, 2 bit, 3, whatever. Now, the concept is regarding colors. I was talking about how many colors are possible, combinations of etc. So why did I say that? The reason I said that is important because you see there is some confusion. Every year I teach this and students, they are facing confusion that sir, we have told 1 bit, then why two colors are possible? Now think about it. What did I say? I am for this picture number 1. For each of, let us say there are, let us say 200 lengthwise pixels and 100 breadthwise pixels. Let us assume for all these images, okay? So total how many pixels? 20,000 pixels. For each of the pixel in this image, for each of the pixel I am assigning 1 bit. 20,000 total bits required for saving this image is 20,000 bits. Do you agree with this? Okay. Now the question is, this is easy, fairly easy to understand. Everyone will understand. But what I'm trying to drive at now is another thing. Although I am allowing 1 bit I am allowing one bit to represent one pixel, but what is the number of colors that is possible in this image? What are the outcomes? If I ask you, what are the outcomes if I assign only one bit per? Forget this per channel now. Don't look at this. Listen to what I'm saying. If I am assigning one bit to each pixel, then what can be the outcome for that pixel? It can either be switched on or switched off. If it is switched on, it will light up with this color, that is this violet color. If it is switched off, it will be appearing as black. I mean, no light coming out of it. So together, how many colors are possible, combinations are possible, outcomes are possible? You have all done permutation combinations in your maths class. So together, how many combinations are possible? Very simple, two. Either it is on or off. So total number of outcome is what? Total number of colors possible is what? 2. So how did we find it out? 2 to the power 1, 2 to the exponential of 1. Either it is switched on or it is switched off. Is it not? Bit depth is 1. This is a 1 bit image. But total number of colors possible in this image is 2. Okay, understood? Next, in the second image over here, okay, so let's say they have written over here 2 bit. This is the bit depth is 2 bit. This is a 2 bit image. If I ask you what is the bit, 2 bit. So why 2 bit? Because I am either assigning violet or green, 2 colors. This is 2 bit. Okay. Now, what is the number of colors that are possible? Now, that also I have explained earlier. Either it can be violet, either it can be green, or it cannot be violet, or it cannot be green. Okay, so that means what? That means total number of possible colors is 2 to the power 2 is equal to 4. Total number of colors. In this case, there are 4 bits. 4 bits per pixel. I have assigned 4 bits. Okay, so that means if this is 200 by 100, so total amount of memory that is required to save this image is what? For this single thing, that is 200 into 100 into 4. Now per channel, why I am saying per channel, this concept of per channel I will be talking about a little bit later, because you need to understand the various color modes, then I can go for per channel. But simply put, right now, know this. Total number of bit information, total number of memory allocation required to save this particular image is 4 bit images, 200 into 100 into 4 bits. Okay. Now, similarly, how many outcomes are possible, how many colors are possible? Same, 2 to the exponential 4, 16. And finally, we come to 8 bit. For each pixel, I have assigned 8 bits of memory allocation. So total number of colors possible is 256. Now you see one thing, why I have given this grayscale, intentionally I have given this grayscale. This grayscale defines the continuity or smoothness of the image. For 1 bit image, either there is image or there is no image. In 2 bit image, there are 4 tones it can be reproduced. So in case of 1 bit image, how many tones can be reproduced? 2 tones. In case of 2 bit image, how many tones can be reproduced? 4 tones. In case of 4 bit image, how many tones can be reproduced? 16. In case 16 tones. In case of 8 bit image, how many tones can be reproduced using the image per channel? Per channel I will explain later on. Okay. So in this case, just try to understand. So for 8 bit image, how many tones are possible? 256. How did we get 2 to the exponential 8? 256 tones are possible. That means what? That means that when I am going on increasing the bit depth of the image, the quality of the image is increasing. Is it not? Why is it increasing? You just simply see the image and simply see the gradations, the grayscales below. Greater the number of tones is very interesting and very important. This concept will again come back when we go for that resolution and all those concepts. This concept will again come back later on. Okay. So greater number of tones means what? The image will appear to be more continuous. And in this case, it is very much discrete. Either there is image or there is no image, isn't it? In this case, either there is image or there is no image. Either the pixel is lighting up or it is not. And this one bit concept will also, in the previous class, I think in the first lecture I told you one term, that is one bit TIFF, if you had listened properly. So this one bit TIFF comes from the same concept. We'll be using this for CTP plate preparation during the ripping process later on. So this is what the basic concept of bit depth is. So it is basically how much amount of memory you are allocating to a pixel to represent a particular image. Greater the number of bits you are assigning, better will be the image quality. This is a very common sense thing. Okay, moving on. Now, I don't really want to come to histogram at this point. I just want to show you this color mode. Histogram will come later on. Let us first talk about a little bit about the color mode. Here, very nice image they have given over here. See, this is a 1-bit image. This is a 1-bit image, and this is, let us say, 8-bit image. The problem why I was referring to this per channel, why there was some confusion, because it's a color image. It would have been nice if this image would not have been in color, but for understanding purpose it is better this way. Okay, now let us get a little bit deeper into various types of color modes and the application of bit depth in our case. So this is a 1-bit image. That means what? Either there is image or there is no image. These white things, the pixel is lighting up. Black, no pixels are lighting up. But in this case, 8-bit image is appearing to be so many shades. This is a grayscale image. Remember this. This is a grayscale image, 8-bit. That means there in this grayscale there are 256 tones, and because there are 256 tones, it is difficult for the human eye to perceive different tones or the differences between the different tones. You understand what I am saying? That is why it is appearing to be continuous. The question is, what if I increase the bit depth? What if instead of 8-bit, I use 16-bit? Then what? You can of course use, and we do use in certain cases. For many color management work, we need to use 16-bit images, 16-bit TIFFs for color correction, characterization work and calibration work. We need to use that. Even in certain photography, people will tell you where to use your 16-bit images. Of course you can use 16-bit images. You can save or you can upgrade images to 16-bit using Photoshop. You can do that. That means what? That entails what? What does it mean? 16-bit images, I think if you do 2 to the power 16, it will come to certain, more than 2 million or something like that. So that those 2-3 million tones will be there. In a 8-bit image, you are getting per channel, or in this grayscale, you are getting 256 tones. So let us say this is one tone, this is because the tones are so many, so frequently appearing, it's difficult for the human eye to perceive the difference between the different tones available with just 250. Now imagine what is going to happen if you have that at your disposal 2.8 or more than that number of tones. So if you have an image which is 16-bit in quality or having 16-bit depth, then naturally the quality of image will be improved to a great extent. It will appear to be a very nice, continuous tone image. This is the difference between your, digital line tone and your, not line tone, sorry, line art and your continuous tone images. Just increasing the bit depth. Now here, because we are in this topic of bit depth, can you tell me, can you think that I'm asking this question? I'll of course answer this at a later stage, but not right now. Just food for thought. Can you tell me? Can you think of it? If you want to tell me, just send your answers to the Google Classroom platform. Yeah, I'll be able to read your thoughts. In our situation, in graphic arts, in which scenario do we need 1-bit TIFFs or 1-bit images to work with? Obviously, normally we don't print these type of 1-bit images because this useless information. Useless image. What will I do with this so low grade image? No information at all. The original was such a beautiful picture, but when you reduce it to a 1-bit image, all the information is lost. But for us in the graphic arts, 1-bit images are very, very important in one particular area. The question is, in which area, which scenario do we need 1 bit images to work with? Okay, so let us, with this information, I will not go into the resolution part just right now, I will be talking about it later on. But with this information, let us go to the concept of channels, that is color, various types of color modes that we will be using. Okay, now here, in the last slide or so, there was one term that is 8 bits per channel, 2 bits per channel, 1 bit. So what are these channels, right? Now, okay, better still, let me just switch on Photoshop and I'll show you a live, I will give you a live demonstration instead of going with all these theoretical things. Okay, hold on. Yeah, so as I was saying, it is better for us to take a look at the actual demonstration of the entire thing rather than just talk about it. So this is, I have opened a image that I had on my PC in Photoshop. So we will do two things first of all. Okay, first we'll learn about that various color modes. Now you remember I told you there was written 8 bits per channel. What does it mean? I told you to ignore that per channel part for the time being, but now let us learn what is this per channel. Now, as soon as you open any image, you see the name of the tab suggests various or provides you various information about the image itself. What information does it provide? First of all, your image name is being provided at the rate of magnification. It's the current image is at 66.7% magnified view. Then within brackets, it's written RGB slash 8 hash. So RGB means that this image is in RGB mode. We will, when we will deal with color spaces and color modes in your PMS2, we have a dedicated unit on color. There you will learn the various types of color spaces that we use, or there are various what are the various types of color spaces. But right now, let this be set in your minds that any digital image that you see is in the RGB color space. That means the images that you are seeing on your mobile phone or on your TV or on your PC or any digital display for that matter, they are in RGB mode, that is red, green, blue mode. Also, I had told you that ultimately any digital image is basically a matrix. Now, depending upon the number of channels, and so each uh, color, that is red color, green color, blue color. Why are we saying that this is a RGB image? Because this image has got three such channels. That is, one is red channel, green. I'll show you what these channels look like. But ultimately, all these channels or all this entire image, digital image, is nothing but a three-dimensional matrix. Okay, three-dimensional matrix means one matrix containing information about the pixel intensity values of the red channel that is interlaced on another matrix which contains pixel intensity values for the green channel, and similarly another matrix which contains pixel intensity value for the blue channel. So for example, if the size of the image is 100 by 200, then the total dimension of the matrix will be 100 by 200 by 3. That means there are three such matrices, one interlaced on the other. So that is what channel or any basic functionality or basic mode of any digital image. We will be talking about, I don't know if we have a lot of scope to talk about the various matrix operations on image here in this course. I try to teach a little bit about that in the other multimedia course, but nonetheless, let this basic information be right in your mind. Okay, now how to see? So one thing we have cleared up, that this is a 3-channel image because this is in RGB mode. Any digital, by default, any digital image is in RGB mode. Okay, so it normally has got 3 channels, and the other information that you are able to see over here is basically 8 RGB slash 8. This 8 means this is a 8-bit image. All right, so that means what? That per channel, now we will be talking about the bit depth per channel concept. So 8 is the bit depth over here. For the bit depth for this particular image is 8. Now you have to understand this, that bit depth is only referred to as on per channel basis. This is a RGB image, and you are right in saying so, because it is written over there. This is a RGB image, and this is ultimately a digital image, so it must be an RGB image, right? Now the question is, the bit depth. What is the bit depth for this image? Bit depth is 8 bit, right? But it is only on per channel basis. That means there, for each of the channel, that is, let us say for the red channel, each pixel requires 8 bits to be displayed, or total number of bits allocated to one pixel for one channel, that is for one red channel, for one green channel, for one blue channel, each of those channels is 8 bit. That means for 3 channels, if for one channel one pixel requires 8 bits to be allocated in the memory for storing, then for 3 channels each pixel will be requiring how many bits? 8 into 3, 24 bits. So for the entire image, per pixel, it requires 24 bits to be allocated in the memory for storing this image. This is a RGB image, right? Now let us take a look at another mode of image, another color mode. So I want to convert this RGB image into some other color mode. Let us say we are wishing to convert this in Cmyk mode. How to do that? Just simply go to the image option over here, click on the mode, and there you will see all the color modes. Various color modes are given. So right now, because this is in RGB mode, there is a tick beside the RGB color, and because this is a 8-bit image, there is a tick beside the 8-bit. Now see here, it is written clearly 8 bits per channel, right? So that means per channel, per pixel, it requires 8 bits memory allocation. So for 3 channel image, per pixel, it requires 8 into 3 number of bits, that is 24 bits, right? Now if you want to convert it into a Cmyk image, there are many ways to convert it into Cmyk, but this is a quick way to click. So you have to click on the Cmyk color. Now after you click, there will be a dialog box. Some things will be written over there. I will show you what is written. So let us click there. Okay, you clicked it. Now take a look at this dialog box. There are certain information that is given. You are about to convert to Cmyk using US web coated swap version 2 profile, right? So there are a lot of information here which is unknown to you. You don't know what US web coated is, you don't know what swap is, you don't know what version 2 is, and you don't know what a profile is. So this entire sentence does not really make sense right now. But let me assure you that it will make sense once we learn colorimetry, color management, ICC color management for that matter, in PMS2. So once we learn, we will again come back to this entire process, okay? Once we come back to this, once we learn all these things in our PMS2 course, all these things will start making sense. But right now, our intention is not to learn what this profile and what all these things are. Right now, we are talking about bit depth and total number of bits required per pixel for a certain number of channels. So for that purpose, just remember that we are trying to convert this RGB image into a Cmyk image. Okay, so simply we'll click over here, okay, and as soon as you click OK, you see file name remains the same, magnification remains the same, but instead of RGB image, the image now is getting converted into Cmyk. See, it is written Cmyk, and the bit depth remains the same. Okay, now the reason I showed you this, let us now take a look at the individual channels. So for this Cmyk, initially in our case of RGB image, how many channels were there? 3 channels. Okay, for 8-bit image, each pixel in a single channel requires how much amount of memory allocation? 8 bits memory allocation. So for 3 channels, each pixel requires how much? 8 into 3, 24 bits. But here you have converted your image into a 4-channel image, that is Cmyk image. So the bit depth remains the same, 8 bits. But how many amount of, what is the memory allocation for a single pixel for this entire image? It will become 8 into 4, that is 32. So the total number of bits required to to display one pixel in this image is 32, and total amount of memory allocation required to display one pixel in a single channel for this image remains 8. That is 8 for RGB, that is 8 for CMYK if it is we are talking about 8-bit image. But for the entire image, for 1 pixel, the total number of memory allocation for RGB image is 24, for CMYK image is 32. Okay, hopefully this was clear. Now let us take a look at the different channels. So I will convert it back to RGB image. Okay, yeah, now again I have converted it back to RGB image. Now let us take a look at the channels. Depending upon the what version of Photoshop you are using, your interface might change. One quick way to check channels is always go to the window panel and click on the channels. Yeah, channels dialog. Right now here you will see there are this channel option that is given. Usually this right side panel also provides you the channel. Now you see there are how many channels? 3 channels. In this topmost channel, which is given written as RGB, this is a composite channel. That means this is all the channels together when they are coming. Then this is the mode. This is what you are viewing. The present, whatever we are seeing on the screen is the composite mode. Now, if you want to see a certain specific channel, you can do that. Just switch off all the other channels. Let us assume that we want to see only the blue channel. So you are able to click on that only the blue channel, switch off all the other channels, and you will whatever you are seeing on the screen is the blue channel. Similarly, you are also able to see individually the green channel and the red channel, right? And this is what the composite image looks like. Okay, now take a look what happens when we take a look at what happens to the channels once we convert it into CMYK mode. Yeah, so this is now in the CMYK mode. See, I have changed it to CMYK mode again. Now let us take again a look at the various channels. See how many channels are there? 4: cyan, magenta, yellow, black, and the topmost channel is the composite channel, whatever we are seeing on the screen. Now let us say we want to take a look at the black channel. This is where the black pixel intensities are lit up most. This is where the yellow pixels are lit up, right? So similarly, we can check the various individual channels. This was the first part that I wanted to show you. Now you know what is the difference between bit depth and total number of bits per pixel for the entire image. That is, whenever we are talking about bit depth, we will always say that 8 bits or 16 bits per channel. But total number of bits required for representing 1 pixel for the entire image will depend upon how many channels are there. If it is a 3 channel, then 24. If it is a 4 channel, then 32 bits, right? But whenever you are asked what is the bit depth, you will always say whether it is 8 bit or 16 bit, but always mention 8 bits per channel or 16 bits per channel. Alright. Now, as for the second component that I wanted to show you, that was about something which is known as the image histogram. Okay. Now, how to open the image histogram? Go to similar process. Here also we can click and we can open histogram, but let me show you the generalized method. Go to window and then click on the histogram panel and it will be open. Oh, this is in Cmyk mode, so wait, let me just change it back to RGB mode. Yeah, okay, you can do it in Cmyk mode also. I just wanted to give you a view of the, I don't want to talk about the Cmyk mode a lot right now because we will be talking about the Cmyk mode, but not at present. Once we know what ICC color management is, and once we know how to convert these images, RGB images, into Cmyk using ICC color profiles, then we will be talking a whole lot about the Cmyk images. Okay. Now, histogram, the term, you must be knowing this term. I think in 10th standard or the school level, you must have done this, drawn some histograms in your graph papers or plotted something similar. What is a histogram? It's nothing but a frequency distribution, some form of frequency distribution. How much quantity or what is the occurrence of a certain event within a sample space, that is represented by a histogram. That is a generalized definition of a histogram, right? Now, specifically when we are talking about image histogram, we will be dealing with certain things. Now, just before I go into all this, the channel wise histogram, let us just take a look at the overall histogram. The topmost image that you see on your screen, on the right side of the screen, this is what the image histogram looks like for any particular image. All right. Now, this is the composite histogram. That means this is the combined histogram, you can say. Individual channel wise histogram is also there. I will explain what a histogram is, what information can you derive from a histogram. All this I will explain, but let us get the idea about what we are seeing on the screen right now. Then I will slowly and steadily start to explain what each of these means. Now, here you will see that this is the, as I told you, this is the combined histogram, right? And this is your individual histogram, channel wise histogram. Now, in any histogram for that matter, if we are talking about here, then along the x-axis, this is the x-axis, you will have the various pixel intensity values or the tonal values. So for a 8-bit image, what will be the range of these tonal values or pixel intensity values? How many tones are available in a 8-bit image? 256 number of tones. Normally, we start the lowest tone, that is the switch off, pixel is not lighting up. That tone, we consider that to be 0. And the highest pixel is having highest pixel intensity value, that tone we say to be 255. So from 0 to 255, we have got this 256 levels of tones or 256 levels of pixel intensities, right? So that is given along the x-axis, and that is referred to here as known as what Photoshop calls it as levels. That means level is what is the tonal value. That means what is the pixel intensity for that certain pixel. So what is for a 8-bit image? Minimum pixel intensity is 0 and maximum is 255. Similarly, for your this thing, your 16-bit, minimum pixel intensity is 0, maximum pixel intensity I think is 65,535. So that makes total pixel intensity or tonal values of 65,536 number of levels, 36 number of tones. Okay. So x-axis is now clear. What about the y-axis? Y-axis represents the total number of pixels there are. How will you, what information, where is that information given? See, it's written over here, pixel. This particular image has got a total number of pixels of 1,29,600 pixels. So here, naturally, along the y-axis, this point is 0, and the maximum point over here is 1,29,600. Okay. So if you move your cursor, see this is the level 0, that means this is 0th pixel intensity, and if you move the cursor to this point, to the extreme right hand side, here you will see the pixel intensity is 255. See the count, just follow what is the count given below the pixel, below the level. It is 2. That means this curve represents how many pixels in this image has what pixel intensity values. So let us say that for any given arbitrary point, this is level 44 or 43, right? So consider this to be the maximum value. This is the peak of the histogram over here, as you can see over here. This is the peak of the histogram. Peak means here what is the peak? 1,29,600. That is the maximum number of pixels there is in the image. This is the peak. So if you draw a straight line vertically downward towards the x-axis, you will find out that the level for this particular point is 43. This means what? That maximum number of pixels in this particular image has got a pixel intensity value of 43. There is another peak somewhere over here, right? If you draw another vertical line, if you point it here, see the level becomes now 68, right? That means there is another peak which has, or another, you can say that quite a lot amount of pixels have got this pixel intensity value of 60. So that means what? This is a map. This histogram is providing you a map on how much of the pixels is having what pixel intensity values. If you take a look at the count, you will find out that here around around 3300 pixels is having a pixel intensity value of 70. Similarly, here also 4300 pixels is having a pixel intensity value of 44, right? So similarly, as you move your cursor ahead in this direction, in any direction for that matter, will get the count as well as in the level. That means these many pixels are having sorry, these many pixels are having this particular pixel intensity value. So what information can you drive from this? You see, there is a overall peak that you can observe in the highlighted. This is the shadow area, right? 0 means pixels are not lit up, and 255 means all the pixels are lit up with maximum intensity, right? Now along the shadow area you will see there are two peaks, but majority of the, if you see, majority of the pixels are having a pixel intensity value somewhere 120 130 like this. That means majority of your pixels are having pixel intensity value somewhere in the mid-tone area. That means 120 130, this is the mid-tone area. If you break up the range between 0 to 255, that is somewhere in the midpoint of the pixel intensity values. So that means what? From this histogram, it can be told what type of image you are looking at. If your majority of the pixels were in this left part, that means there in that particular image, shadow area would have been higher. Because we have got a majority of the pixels in this central area, in the mid-tone areas, that is why this is an image which has got the highest amount of mid-tone areas. Conversely, if a large amount of pixels were in this area, in this highlight area, towards on the right hand side, that means towards 255, then we would have said that okay, this image is having greater proportion of highlight area. Okay, so this is what is the significance of the histogram. That means without even looking at the image, if I only give you an image histogram, you will be able to infer what type of image we are looking at. Image, this type of image is known as a mid-key image, because most of the image has got middle tones, or the middle tones are dominant in this particular image. If in certain other image the shadow areas would have been dominant, then we would have called it as low-key image. If in another image the highlight areas would have been dominant, we would have called it as a high key image. So it is possible for you to understand and realize just by looking at the image histogram without even taking a look at the image itself, to infer what type of image you are looking at, whether it's a low key, mid key, high key image. Okay, so this is what histogram is. Again, I'm repeating, just giving you a brief overview about the histogram. Image histogram is or you can say it draws a relationship between the number of pixels and their pixel intensity values. So in any way, if you move your cursor or your mouse pointer along any point within this histogram, you will get a certain level value and a count value. So level is the pixel intensity level, and your count is how many pixels are having that certain pixel intensity values. For this particular point, you can see that 2000 out of the 1,29,600 pixels that is present in this image, 2,344 pixels are having a pixel intensity value of 121. This is somewhere in the middle, right? And you see the percentile here is at almost 66%. That means most of the images, most of the pixels are having this type of a pixel intensity value, right? So that is why we can say that just by looking at this histogram, we can say that this is a somewhere mid key image. Now compare your analysis of a histogram with what you are visually seeing in front of your screen. Do you agree that the image that you are seeing in front of you is a mostly mid-key image? That means it contains majority, or there is a dominance of middle tones in this image. Of course you can say that. See, the sky is in the mid-tone area. Most of the mountain, apart from the lower section, entire mountain is in the mid-tone area. The sky, the area where the sky and this horizon area, this is a highlight area, but most of the image is appearing to be a mid-tone area, is in the middle tones. There is a dominance of middle tones, which matches with our analysis of the histogram as well. So this is the importance of histogram. Just by looking at it, we can infer what type of image we are looking at. Along with this, image histogram also provides us with various image statistics. For example, you see the mean values here. What does this signify? So as I told you, this is we are looking at a 3-channel image. This is a RGB image. Now, what is the number of pixel in this entire image? There are 1,29,600. So for this, all these pixels within this image, if you find out, if you just note down all the pixel intensity values for 1,29,600 pixels and calculate the average of the pixel intensity value, so the level values. That means how many sample, what is the sample space there? 1,29,600. You add it up and divide it by 1,29,600. The value that you get, that is the mean, that is over here 102.9. This also signifies, mean signifies what? That most of it, or the average value, resides somewhere in along that image. Okay, along that 102, that means 103 pixel intensity value. This also signifies that most of the image is somewhere, or there is a dominance of mid-tone areas in the particular image. Okay, next we have standard deviation. Standard deviation is calculated how? Modulus of x minus x bar, where x bar is your mean. That is 48.3. This is a very high standard deviation. What does this signify? What does this standard deviation signify about this particular image? Or can you, if I reframe my question, so I will not tell you the answer for this question, okay? I'll just ask the question, let you think on this, and get back to me via your Google Classroom. I'll put this question in Google Classroom as well. See, standard deviation here is 48.3. I am asking you, or I am giving this information to you. This is a extraordinarily large standard deviation, very high standard deviation. Can you justify how, just by taking a look at the histogram, even if you don't look at the image also, just by taking a look at the histogram, can you justify why the standard deviation for this image is so high? If it would have been 5, 10, I would not have said anything. But here you are seeing the standard deviation is 48.3, which is extraordinarily high. By looking at the histogram, just by looking at the histogram, can you justify, or can you tell me, or can you even correlate this value of, this very high value of standard deviation with the histogram we are seeing in front of your screen? Alright, so this is a question that I have asked you. Next, so you know what standard deviation means. I have already told you, and you know this from your 10th standard maths also, so that is not something very critical. Okay, now next we have got the median value. Median value is 97. Now, median means the most frequently occurring sample in your sample space. That is the median. So that is 97. This also signify, because most of your values, most of your pixel intensities are at 97. That means that is somewhere also in the mid-tone areas. So your inference by visually looking at the image is justified or backed up by your analysis of, visual analysis of your histogram, as well as the mean and median value. This is justified. What is not justified, what I have missed out, and I have asked you a question, is why the standard deviation is so high. That is something you need to answer and send me your answers. Okay, so hopefully histogram is clear. Now this is the composite, as I told you, this is the composite histogram, and there is you can see there is this channel wise histogram also. Overall nature of the histogram will remain the same. There is a peak here, there is a for the red channel, there is a peak here in the, for the green channel. So together they are almost overlapping with each other. That is why you are getting the first peak. But for the blue channel, it is not really overlapping. That is why in the composite image you are getting another second peak. This second peak is corresponding to the blue channel, and the first peak is corresponding with the combined effect of the green, red and the green channel, and the overall other areas almost remains the same. Okay. So this is all about the image histogram and what information you can derive from an image histogram. The various image statistics. These image statistics for us is not really that important, but when we are talking about image manipulation, maybe we are talking about adding some filters, manual filters, or we are doing some image arithmetic in image processing, then the statistics becomes very much important. Okay. So this is about the image histogram, and I have already told you about the various types of color modes and the bit depth, what bit depth is, and what is the meaning of that per channel term, right? And total number of bits required per pixel for that entire image depends upon the bit depth as well as your total number of channels, is it not? So this is what the significance of bit depth, and also I showed you this histogram also. So this is what. So let us continue our discussion. Okay. So now hopefully this concept over here that I have written, this is clear. So per channel, if we are working with the RGB image, the total bits per pixel required is 24 bits, because per channel requires 8 bit per pixel. That is this. So total number of colors that is possible per channel is 256. So total number of colors that is possible together for the entire composite image is 256 into 256 into 256. Right? Next we have Cmyk image. So here also total number of colors that is possible is 256 into 256 into 256 into 256. This is okay. So this is what the concept of bit depth is, and I hope this concept of color modes is clear to you. Now I missed this slide earlier just to show you one important thing. I came back to this slide. So the concept of histogram is clear. Along the x-axis, what do we have? We have the levels. What Photoshop call levels, we'll call the pixel intensity value or tonal value, whatever you want to call. Along the y-axis, we have got the number of pixels, right? Now, one important and interesting thing that I want you to notice from this particular two histograms that is being shown here. You see, this is a histogram of a 16-bit image, right? And this is a histogram of a 8-bit image. What important or interesting aspect do you notice or distinguish between these two images over here, between these two histograms? The overall shape of the histogram seems to be the same, right? But what is different? The histogram of the 8-bit image seems to be very discontinuous. That means total number of tones have reduced. The total number of tones here is what? 0 to 256, is it not? And what is the total number of tones over here for a 16-bit image? Is from 0 to 65535. Sorry, I made a mistake. This is 0 to 255. So total number of tones is 256, and over here total number of tones is 65,536. So the minimum pixel intensity value is 0 and maximum pixel intensity value is 65,535. Right? One interesting thing that I want you to notice is that the nature of the histogram is very discontinuous in nature. Information is lost. Why? Because those tonal values are not present over here. If you take a look at this particular grayscale, it's very much discontinuous in nature. This is continuous. That means some information is lost in comparison to higher pixels, higher bit depth images, right? That is visible in this histogram also. If you are working with a 8-bit image, sometimes it may happen so that some information may be lost, because that many number of tonal values, that many number of pixel intensities values are not present in the image. Where will it get that information from? So naturally, if the amount of information that can be stored in a 16-bit image is higher, therefore the histogram will appear to be much more continuous in comparison to a histogram of the 8-bit image. Okay. So with this, let us do another thing. Now, this is a very simple problem. This I need you to do. I'll give this question in the Google Classroom also. You need to submit your answers within the deadline that I will be given in the Google Classroom. So see, something is given over here. Some information is given and some other information is wanted from you. Right? What is given? You have been given a image size. You have been given an image which is having an image size of 10 by 15 centimeters. Okay. The image resolution is also given 300 ppi. That means, let us say, actually, okay, fine. This is the image which is having 10 centimeter by 15 centimeter. Okay. Now, image resolution is what? How many pixels are there per inch of that image? Let us say this is 1 inch. Okay. Within this 1 inch, there are how many? 300 pixels. Like this, there are 300 pixels. That is what image resolution is. I'll be talking about resolution, but with this information also you can do this math. No problem. Again, another information is given. Bit depth is given. What is bit depth? 8-bit. Naturally, next question is, okay, bit depth is fine, but what is the total number of channels in this image? That is also given. It's a RGB image. So 3-channel image. So these four informations are actually given to you. Now the question is, what is the total amount of memory that is required to store this image? And you have to calculate your answer in megabytes. Okay. So one hint I am giving you: 8 bits equal to 1 byte. 1024 bytes equal to 1 kilobyte. 1024 kilobytes is equal to 1 megabyte. Okay, this information also I am giving you. All this information is given. Now just simply find out the amount of memory, computer memory, that is required to save this image in megabytes. Okay, so if you have understood all the concepts that I have talked throughout this class correctly, then you will be able to solve this problem. It will be a very easy problem. Okay, so thank you for listening. Meet you in the next lecture.